Okay, and as I mentioned before, we're going to be taking a look at probability, and we're going to be taking a look at it from the perspective of sampling and how it's going to affect our judgments when we try and predict certain associations between the different variables, between different groups, and so on and so forth. You guys, later on when you get into the lecture, you're going to learn something about these things called Venn diagrams, VENN. And this particular Venn diagram illustrates a population or a sample of students. Okay, we could say this population or sample of students represents 100 students, right? And that's the entire world of students. You could instead look at it as 100% of the students. Okay, so now within this group of 100 students or 100% of the students, 15 or 15% of the students, no, that's a typo there. No, oops, let me get in there and correct that. No SAS, which is a software package. We're using SPSS. That just happens to be another software package. Um, and and 35 of the students, or 35%, depending on how we want to look at it, no SPSS. And as it happens, there's some overlap between those students. 5 of those students know both. The way we would illustrate that in a Venn diagram is we show this entire space representing the entire sample or population, this yellow area over here, this whole universe bounding the 100 students. Within that group of 100 students, 35 of those students know SPSS, right? That's this green oval here. And 15 of those students know SAS. And we also notice that there's some overlap here. 5 students know both. Okay, so this number represents the number of students that know SAS. This number represents the number of students that know SPSS. So I'm going to ask you to consider this. Okay, what's the probability that a student knows SPSS? Right? Think about that for a second. What do you think the probability that within this population or sample that a student knows SPSS? Well, there's 35 students that know SPSS out of 100 students total, or 35% out of 100%, right? So the probability of any randomly selected student that we would pick from this population is 35% that they would know SPSS. What's the probability that they would know SAS? Well, 15 students in this population know SAS out of 100, right? So the probability that we would randomly pick one student and they would happen to know SAS is 15 divided by 100, or 15%, or 0.15 is a proportion. Okay, good. All right, it seems pretty obvious. Okay, so now, really doesn't matter if you use a proportion or a percentage. It's just another way of expressing it. Kind of like when we were working with age adjustment, you could express the same number as a proportion as a number per 1,000, a number per 100, a number per 10,000, a number per million, right? That in this case, percentage is just a number per 100. Really, that's really what it represents. So it really doesn't matter that much. Later on, as we get into statistics, there may be certain times when by convention you would use a proportion, or by convention you might use a percentage. But I think proportions pretty common. I'm pretty comfortable most of the time using proportions. Okay, but we understand that that's 15% as well. Okay, so now I'm going to introduce a new kind of situation here. Okay, we have 2 words that we use sometimes when we describe how these different groups interact. One of the words is union, and the other word is intersection. When we have a union, we're talking about combining the 2 students. In other words, what students know either SPSS or SAS, that both conditions satisfy what we're looking for. Okay, how many students know SAS or SPSS total within this group? Anybody want to make a prediction on that? What do you think? It's a little tricky. Let's see. Well, 15 and 35, you would think, right? Well, that's not really true, is it? 5 of the students overlap. They know both. So really, there's 10 students that know only SAS. There's 30 students that know only SPSS. And there are 5 students that know both. So if we want to know what the probability of a student knowing either SPSS or SAS, in other words, the union of those two groups, that's going to be equal to 15 plus 35 minus the 5 divided by 100. Okay, I'm going to put a parentheses around there so it does that subtraction and addition operation first. Okay, and it's 45%, not 50%. Okay, now I know some of you guys I purposely tricked some of you. This was a little unethical of me. I purposely tricked some of you by jumping to this so quickly. But do you see why it's 45 instead of 50%? You guys are you guys comfortable with that? Okay, good. Okay, right? You get the idea that there's an overlap there. So it's really these 15 and those 35. If they didn't overlap with one another, then it would be 15 and 35. But since there's overlap, there's 5 individuals that know both, right? So it's 10 here, 5 here, 35 here. One way to calculate that is just add up the 15 to 35 and subtract the intersection between the two of them, because it's counted twice when you do 35 and 15, right? Because it's counted once with SPSS out of those 35, another time with SAS, that 5 is part of those 15. So if you just add 15 and 35, you're counting those 5 guys twice. Okay, so that's why we subtract it. Okay, and there'll be formulas for doing that as well. Okay, so now I'm going to introduce another concept, which is called intersection. Okay, and intersection means that that's the case where they know both. In other words, that they know both SPSS and SAS, the intersection of the two groups for no SAS and no SPSS. And we already know that the intersection of that group is equal to 5 students out of 100. Okay, which is chance of the odds of us randomly picking a student out of this group, and they're knowing the intersection, being in the intersection of SPSS and SAS. In other words, knowing both is only going to be 5%. Okay, and then finally, we're going to talk about one other concept, and that's the idea of conditional probability. Now, this little formula that I put here represents something that there's a little ASCII character here in the middle here. It's called a bar. It's just a straight up and down line. It's a little bit bigger than the other letters. The way I would express that is the probability that a student knows SAS, given that they know SPSS. In other words, given that this has already occurred, that we're only looking at students that know SPSS, or that a coin has already been tossed and it's a heads, or a card has come up and it's a king or something. Given that this has already occurred, that we're dealing only with students that know SPSS, what's the probability that they also know SPSS? Okay, so let's think about that. What's that going to be equal to? That's going to be equal to, let's see, what's the probability of someone knowing SPSS? Well, there's 35 students that know SPSS, correct? Okay, over 35, right? So now what's the probability that any of those 35 students would know SPSS? Well, the way we see it here, 5 out of those 35 students would know SPSS. So given that the student knows SPSS, the probability that they would know SAS also is going to be 5 over 35, or about 14%. Okay, not magic, not hard, but it takes a little bit to now that for some of you this union, intersection, this conditional probability of an outcome of something happening, given that some other outcome has occurred already. These are kind of maybe new concepts for you. Okay, so we're going to move on to another example of how we might use this. Okay, let's go move on to the next sheet. Okay, let's see. Let me just make sure there's no questions here yet. The SAS part is, if we had, let me go back to that. That's an interesting question. What if this had gone the other way, that I asked you, what's the probability of a student knowing SPSS, given that they know SAS? In other words, these were reversed. That given that SAS had occurred already. In other words, given that we're only dealing with students that know SAS, we know that's the case, right? What's the probability that they would also know SPSS? Well, we see out of the 15 students that know SAS, 5 of them know SPSS as well. So the probability a student knows SAS, given that they know they know SPSS, given that they know SAS, the opposite way, right, is 5 out of 15, or 33% chance. Right, good work, Tara. Yes. Okay.